Now, we're going to take up one more problem on projections of laminas. How to analyze this problem number 96 and how to solve by using manual sketchbook. The problem reads as the regular pentagonal lamina of 25 mm side is resting on one of its sides on HP, while the corner opposite to this touches VP. If the lamina makes an angle of 60 degree with HP and 30 degree with VP, draw the projections of the lamina. This is the problem. So first, as it says, one of its sides on HP, so obviously we have to start from HP. Since we have a pentagonal lamina, it's the odd number side, therefore one of the edges has to be perpendicular to VP. So we have to place the lamina, a pentagonal lamina, in such a way that one of the edges has to be perpendicular to VP. So the edge which we are keeping perpendicular to VP is AE. Then the surface makes an angle of 0 degree with respect to HP. Now the lamina is parallel to HP. Once as we see all the sides, which is A dash, B dash, which is B dash, C dash, C dash, D dash, D dash, E dash, and E dash, A dash, all the sides are parallel to HP. So that means all the sides are on HP. So that means it is parallel. So therefore, we are getting the true length. So what is the true length here? The side of the true length of this pentagonal lamina is 25 mm. Then we can see here also that a pentagon of one of the sides is perpendicular to XY line or perpendicular to VP. And as we look from the front view, we can see ABC is near to the observer. So A dash, B dash, C dash is visible. And D and E is away from the observer. Therefore, D dash and E dash becomes invisible. So we can see that is been kept in bracket. Now, then he says it is resting on one of its sides on HP. So the side which is resting on HP is the side which is perpendicular to VP. So we can see that AE is the side which is resting on HP, such that the surface makes an angle of 60 degree with HP. So when you are rotating this 60 degree with respect to HP, what happens in the front view? In the front view, the surface of the lamina is still perpendicular to VP. So that is the reason why you are getting a line in the front view. So you are going to get 60 degrees to HP. And when you look from the top view, you are going to get a pentagon which is in apparent shape. But to have the clarity, we have not shown that pentagon here. And we can see here, it is one of the sides is resting on HP. And when you look from the top view, you can see AB, BC, CD, and DE all are in apparent length because A dash, B dash, B dash, C dash, C dash, D dash, and D dash, E dash are all inclined to HP. So in HP, it is in apparent length. Whereas A dash, E dash is perpendicular to VP and parallel to HP. Since it is parallel to HP, AE, we are getting the true length here. So this is how we can be able to analyze in the second position. Now when we go to the last one, while the corner opposite to this touches VP, which is the corner opposite to this? The corner opposite to this AE is C, touches VP. So it is touching VP here. So once it touches VP, obviously you're going to have a surface perpendicular to profile plane. When you look from the left side view, you will going to get a line here. Since the surface is inclined to HP at 60 degrees, so obviously when they are rotated by 90 degree and keep the surface on VP, the sum of these two angles should be always equal to 90. Therefore, the surface will be inclined to VP at 30 degrees automatically. So as we see from the left side view, E, D, and C is near to the observer. So E double dash, D double dash, and C double dash is visible. And A and B is away from the observer. So that becomes invisible. So you can see here. So what we can do here is you rotate the second position top view such that the C should be on the vertical plane. So I have to rotate only on by counterclockwise direction such that the C will be on VP. Rewrite the second position top view here, and then projecting it to the front view, you will going to get the corresponding front view. Once you get this, so this is the surface which is inclined to VP and also inclined to HP. So when the surface is inclined to both the planes, obviously in the profile view you are going to get a perpendicular line. So that means it is perpendicular to the profile plane. So draw the x1y1 line and draw the side view so that you can see here this angle will be 60 degrees and that angle will be equal to this angle by 60 degrees. And then this, once this angle is 60, obviously this angle will be, the sum of these two should be always 90 degrees. So 90 minus 60, which will automatically give 30 degrees. That will be the inclination which is with respect to the vertical plane. This and this is what are they same. As we see from the left side view, CD and E are near to the observer. So C double dash, D double dash and E double dash are visible. A dash and B dash is away from the observer. So A double dash and B double dash is in bracket. So this is how we will be able to analyze this problem. Now we will going to try to solve this problem using sketchbook. So how to do that? First we will going to draw the XY line with a very thin line, and you mark X and VP and HP and here as Y. So first we want to start with the pentagon to right. So make one, draw a vertical line of 25 mm here, and then by using the and mark this point as small a and small e. Then by using the protractor, you measure an angle with respect to AE by an angle of 108 degrees and then draw an inclined line here. Similarly with E as center, with respect to AE, you measure an angle of 108 degrees and then draw an inclined line. By using the compass with A as center, taking the radius of 25 mm, cut an arc on this 108 degree line here, and also with E as center, cut an arc on this inclined line, and you mark this point as B and D. Similarly with the same radius with B as center, draw an arc here. Similarly with D as center, cut an arc on the previously drawn arc, and you mark this point as C. Then join A to B, B to C, C to D, D to E and E to A with a dot line. Now once we do that, then we need to write the front view. So to draw that, draw a vertical projector from A and E to the XY line. Similarly from B and D to the XY line and from C to the XY line. And you mark this point as A dash, B dash and C dash and D dash in bracket and then E dash in the bracket. As we are joined from A to B, so similarly you join between A dash to B dash, and also you have joined between B and C, then you join between B dash and C dash with a dot line. But since C dash, D dash and D dash, E dash are invisible, and so that is not required to be shown. Once you do that, so this is the front view in the first position and this is the top view in the first position. Now we need to take, since it is one of the sides is resting on HP, take any convenient distance from the first position front view. You mark this point here and you name that point as A dash and D dash. By using the protractor, you measure an angle of with A dash, E dash as center. You measure an angle of 60 degrees with respect to the XY line and then draw an inclined line. Then by using the compass, you measure the distance from A dash to B dash with A dash as center, cut an arc on that inclined line. Similarly with A dash as center, take the radius of A dash to C dash with A dash as center, cut an arc on this point and you mark this point as C dash and you mark this point as B dash and D dash in bracket. Then join A dash to C dash with a dot line. Now you need to write the top view. So to write the top view, Draw a vertical projector from A dash and E dash to the top view, and draw a horizontal projector from A and E. Both these 2 points will going to intersect at this point at A and this point at E. Similarly, draw a vertical projector from B dash and D dash, and draw a horizontal projector from B and D. Both these 2 points will going to intersect at this point and also at this point. You mark them as B and D. Similarly, with C dash, draw a vertical projector from C dash and draw a horizontal projector from C, and both these 2 lines will intersect at this point. You mark this point as C. Then join A to B, B to C, C to D, D to E, and E to A with a dot line. Then once you do that, now we need to go for the third position. So to do that, so opposite to this side touches the corner, opposite to this touches VP. So which is the side which is resting on HP? A dash, E dash. The corner opposite to this side is C dash. So that C is now in front of VP. You make that point to touch on VP. So to do that, so reproduce the second position top view by rotating by an angle of 90 degree in counterclockwise direction only. You cannot rotate in clockwise, because if you rotate in clockwise, then AE will going to be resting on XY line. So what you do, take any convenient position with respect to the second position top view, and you mark this point here, and you mark this point as C by using the protractor, with C as center, measure an angle of 90 degrees and draw a vertical projector downwards. Then by using the compass with C as center, taking the radius of C to this point, from C you transfer that point here. Then draw a horizontal line. Similarly, with this as center, taking the radius of C to this point to A and this point E, both will going to have the same distances. Then from here you transfer on this side, and also from this point to this side. So you got, and you name the point as A and E. Similarly, with this as center, taking the radius of from this to here, by using the compass, from this point you transfer it on to this line. So here you got this point. Then as we see, so from this point, this line is perpendicular to this line. So obviously you draw a horizontal line perpendicular to this line. Then by using the compass with this as center, taking the radius of this to B, and also from this point to D, both will going to have equal distances, and you transfer them from here to this side, and also from this point to this side. Then you mark the point as B and D. Then join A to B, B to C, C to D, D to E, E to A with a dot line. Now you draw a vertical projector from A to the XY line, and also from E to the XY line, and you mark this point as A dash and E dash, and draw a vertical projector from B and D, and also B dash and D dash. Draw a horizontal projector. These 2 lines will going to intersect at this point B dash and also at this point D dash, and draw a vertical projector from C to the front view, and draw a horizontal projector from C dash. Both these 2 lines will going to intersect at this point, and you mark this point as C dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and E dash to A dash with a dot line. Once you do that, then taking any convenient distance from the third position front view or the top view, draw one x1 y1 line, and then by using the protractor, you measure an angle with respect to this point by an angle of 45 degree in the adjacent to HP, and then draw a 45-degree line. Then you mark this side as RPP. Then draw a horizontal projector from C, and draw a horizontal projector from C dash, and then draw a vertical projector from this point towards the top side. Both these two lines will going to intersect at this point. So we got C double dash. Then draw a horizontal projector from A dash and E dash to the side view, and draw a horizontal projector from E and A to the 45-degree line. And from this point, you draw a vertical projector. Both these two lines will going to intersect at this point, and you mark this point as E double dash and then A double dash in bracket. Similarly, draw a horizontal projector from D and B to the 45-degree line, and from here you draw a vertical projector to the side view, and draw a horizontal projector from D dash and B dash. Both these two lines will going to intersect at this point, and this point will going to be marked as D double dash and B double dash in bracket. Then join C double dash to E double dash with a dark line. And then, so as the surface is inclined to both HP and VP, obviously the surface will be perpendicular to the profile plane, wherein the 60-degree with respect to XY line is the HP, and 30-degree with respect to the X1 line is VP. So then show the dimensions accordingly. So this is how you will be able to solve this problem using the sketchbook. Thank you.